It's a $20 million project which will shape the way houses are built and inhabited for decades to come. Within a cavernous environmental chamber at the University of Salford, 2 full-scale family homes have been built, incorporating prototype materials and bristling with energy-saving technology and devices.
One of the things that we can do at Energy House 2 that you can't do in traditional field trials is to take some risks. So we can take technologies that are right on the cusp and we may not know if they're going to work really well or not. And this gives us a chance to compare some of the things. So the Bellway house that you see behind me has got 4 different heating systems. And using those control conditions, we can compare air source heat pump at the back, air source heat pump in the roof, and the 2 types of infrared heating that we've got to really understand which one's going to bring the biggest benefit to the consumer.
Inside the houses, smart heating controls which can learn and adapt automatically to the homeowner's habits. Infrared heating replaces convection radiators. Sensors throughout the rooms feed data back for analysis. And the outside of the houses can be subjected to a temperature range from a baking 40 degrees Celsius to an Arctic -20, with optional blizzard conditions.
It's a genuinely extraordinary experience, standing here in a climate-controlled chamber with snow falling on my head and 2 full-size houses inside behind me. But the serious purpose of this is to put technology and materials that are going to be going into new houses in 5 to 10 years' time and putting them under the kind of stress and duress that they will be facing in 50 to 100 years' time as climates change.
The UK's housing stock is the oldest and least energy efficient in Europe, and more than 4/5 of those homes are still heated by gas-burning boilers.
We have a digital thermometer system.
The advances being tested in the Energy House are not just intended for new build properties.
A lot of the technology we'll be researching in this house will be applicable to retrofit projects as well. So things like digital thermostats on radiators, central heating systems that learn, they can all be adapted into existing properties. Clearly, as a new build provider, we're able to build these into the fabric of the home, but it is possible to put a lot of these technologies into existing homes as well.
40% of the UK's carbon footprint comes from the built environment. Achieving net zero needs a step change in the design of new buildings and the upgrading of old. But knowing what actually works is crucial in making sure government policy hits its targets.
What's great about this project, we've got government coming here because they're learning from our findings about how it can inform the regulations of the future as well, because it's quite important that the regulations are realistic and we're able to deliver them, but also they have the right impact.
Our homes are usually the biggest financial expenditure we have in our lifetimes. This groundbreaking research project hopes to ensure that those future homes are fit for future purpose. Paul Brennan, Al Jazeera, Salford.